Now, the composition of functions is the process of using the value of one function as the input value for a second function. So we have some function f, but inside of the parentheses, instead of having the independent variable x, we have a second function, g of x. F of g of x can also be written this way, f of g of x. Just make sure you do not confuse this with f of g of x is equal to g of f of x. In this example, f is the outer function and g is the inner function. But on this side, g is the outer function and f is the inner function. And this does affect the final outcome of the expression. The best way to take a look at this is for us to walk through an example together. So let's do so. And let's say we were given the two functions f and g, and f of x is equal to x plus 2, and g of x is equal to x squared. We can have a composition of functions including an expression or including a specific number. So we'll take a look at both cases. But let's start by first evaluating what f of g of x would be. So when we have a composition of functions and we're substituting an expression, g of x, in for the independent variable, we first want to write the expression for the outer function. So the outer function in this case is f. So we write the expression for that function, which would be x plus 2. And now step 2, replace each x with the expression of the inner function. So we don't have f of x, we have f of g of x, which means we write the f function, and instead of writing x, we replace each x with the function g, which would be x squared. So we substitute x squared in for x here. So this shows us that f of g of x is equal to x squared plus 2. Now let's say we wanted to evaluate this composition of functions with an actual numerical value. Let's say we had f of g of negative 3. We first want to evaluate the inner function. So g of negative 3 is equal to negative 3 squared. And that's equal to 9. So g of negative 3 is equal to 9. So we want to replace the inner function with the value from step 1, which is 9. So we get f of g of negative 3 is equal to f of 9, since g of negative 3 is equivalent to 9. And now the third step, we can evaluate the outer function f for f of 9. So we have the f function here, x plus 2. So if we substitute 9 for x, we get 9 plus 2, which is equal to 11. So we see f of g of negative 3 is equal to 11. So that is how you would go about evaluating the composition of functions, whether you are substituting an expression or a number. Let's now have you try a few practice questions. F of x is equal to 2x squared plus x, and g of x is equal to x minus 1. Question number 1, what is g of f of x? Question number 2, what is f of g of negative 2? And question number 3, what is g of f of 3? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, write the expression for the outer function. So we were asked to find g of f of x. So the outer function would be g of x, which would be x minus 1. And now step 2, replace each x with the expression of the inner function, which would be f. So we replace this x with 2x squared plus x. And when we do so, we see that g of f of x is equal to 2x squared plus x minus 1. So that is the answer to question number 1. Let's now have a look at question number 2. We're asked to find f of g of negative 2. So step 1, evaluate the inner function, g of negative 2. So we go to g, which is x minus 1, and we substitute negative 2 in for x. And now we have negative 2 minus 1, which is negative 3. So step 2, replace the inner function, g of negative 2, with the value from step 1, which is negative 3, showing us that f of g of negative 2 is equal to f of negative 3. And now we can evaluate the outer function f for negative 3, giving us negative 3 plugged in for x here and here in the f function, which would be 2 times negative 3 squared minus 3. Negative 3 squared is 9. 2 times 9 would give us 18. And 18 minus 3 is equal to 15. So we see the answer to question number 2 is f of g of negative 2 is equal to 15. And that is the answer to question number 2. Let's now have a look at question number 3. We're asked to find g of f of 3. So step 1, evaluate the inner function, which would be f of 3. So we plug in 3 for x here and evaluate, giving us 2 times 3 squared, which is 9. 9 times 2 is 18. And 18 plus 3 is equal to 21. So we have f of 3 is equal to 21. So the second step is to replace the inner function, f of 3, with the value from step 1, which is 21, giving us g of 21. And now we can evaluate the outer function g here for 21. So we plug in 21 for x in the g function, giving us 21 minus 1, which would give us 20. So we see that g of f of 3 is equal to 20.